Hello everyone, welcome back to my training program. So today we're gonna learn about variables and binding operator. So what's the variable? So variable is a location inside computer memory. So if you still remember what we have discussed in the previous lectures, maybe you still remember computer memory. So you have a data here and you have a CPU. So data cannot directly move in CPU. It must go to memory, computer memory, or we call RAM first, and then go inside the CPU. So variable is location inside computer memory. Okay, so keep in mind that computer memory in here is very complicated definition. So for simple, I will assume all the computer is inside RAM. I mean, all the computer memory is inside RAM. Okay, so we have we have a name here. Actually, this is represent a location inside computer memory, and we give this location a name pi. Yes, and then you have a value here 3.14159, and you will assign. I mean, you will store. We're going to store this value inside this location, and to do that you need an operator called binding operator. This is called binding.
Just to confirm, you'd like to call Dincon Mobile? No problem, I won't. Who do you want to call?
So this one we call a binding operator or assignment. Okay. Okay, so so variable for the summation, in conclusion, so variable is a place or location inside computer memory used to store a value. And then an assignment by a names to a value here. So from now, instead of try to remember this long number 3.14159, you only need to remember this one, pi. It's enough. So it's easier to remember, and you can speed up your coding progress. Yeah. And then every time you need to access this value for your coding, you only need to type pi. So it's enough. Okay. Okay, so what is the benefits of using variables? So first, as I mentioned, we give a name to values of expression. So we still remember that this one is I'm sorry. So in here we have an expression here. This one is expression. We have operands. We have operator, operand, and operand. All right. So we calculate this expression first. We have a value here, and this new value will combine with pi and this operator to become a new expression, and then this expression will be assigned to this variable area. Okay, you see that? So why we need a name for this expression? So first, every time as I mentioned before, we reuse the name. Yeah, every time you need to every time you need to use this value, you only need to type pi here, so it's enough. All right, and you can easily to change the code later. So for example, If you don't have a pi and radius variables, you need to calculate area of a circle. You will type 212 multiply radius. Pi. This is pi. Okay, and the radius is 2.2 square. All right. So, and besides area, you need to calculate perimeters. So, you need to type in this one. How can we calculate perimeter? Number 2 multiply 2.2. See that? And multiply 3.14159. All right, you see that? It's very long.
Okay, I found this on the web for...
Okay, so what happens if we need to change the radius? So you don't need to calculate the area and perimeter for radius 212. You need to calculate for 4.2, for example. So you change radius to 4.2, for example. Alright, so you need to update the new value for area and perimeter. So you need to do 2 times. The first one is here and the first one is here. However, in here, if you have a radius value, so you need to this expression become radius multiply pi. All right. So you see that. So instead of update the radius value for 2 places like this one, you only need to update the value for only 1 location, this one. You train the value of radius from 2.2 to become 4.2, and that's it. It will automatically update all the locations you have. Update all the expressions you have used the radius variable. So you see that. So it's easier, so faster. And one more thing, that given a name to an expression will have you to abstract your expression. So what does it mean? It means when you look at here, you can see that if you look at this expression, you cannot understand what kind of perimeter, what kind of area you want to calculate here. But when you look at here, pi radius square, you know exactly it's the area of a circle. So it's easier to understand. And we call it human readable. Okay, it's very, very interesting. Yeah, it's very convenient for coding. All right. Okay, the last concept for today is how Python. You remember that Python is only true for Python. Remember that. So in Python, when you have a statement pi equal to 3.14, what happened? So I already told you that on the variable. Oh, I'm sorry. This one is 3.14. So all the variable and values are stored in computer memory, but the computer memory have many. A computer memory has multiple locations. One of them is we call stack location, and the second one we call heap memory and stack memory. Right? We have stack and heap memory. So the pi is a location inside stack memory, right? And the value 3.14 is a location inside heap memory. So actually, we don't. Actually, the pi here, the pi location, doesn't store the value 3.14. Yeah, it's surprisingly, but it is correct. All right. So what actually happened is we have a location inside heap memory store the value 3.14, and we have a location named pi inside stack memory, and the pi location here store the address of this one, of location of 3.14. All right, so we give the address of this location to the pi value, to the pi location here. So your computer memory actually organized in this layout, similar to this layout. So we have each memory location here, and each memory location has a address, and this address is unique. So it means we never ever have two locations have the same address. Yeah, each location have a different address. All right, and then we give the address of this location to this pi location. You see that? So, and now we call the pi here point to this location. So it means this location is managed by pi. All right, and similar to radius and area. However, surprisingly, when you try to modify the value of radius, for example, radius plus 1, actually it's the expression, it will become 312. Actually, Python doesn't directly modify the value of this location. Actually, Python create another location called, Python creates a new location to store the value 3.2, and then the radius will point to this new memory location, and disconnect the old connection between radius and the reverse location. You see that? So radius will immediately forget this location, and now it's only remember this one. All right, you see that? So we can you can think of this way: the rest of new location will replace the value of the rest of this 212 location inside the radius variable. Okay, so that's it. So that's it for today. So this is enough for the theory. So next lecture we will jump in the practice session. All right, see you then. Bye.